Hello and welcome to this solution video. If you like this video of mine, please give it a thumbs up and subscribe to Math United. Share this video with your friends and you can explore my YouTube channel for more videos like this. If you subscribe to Math United, that will motivate me to make many more videos. Okay, let's start with question number 1. Question number 1 says, find the coordinates of the stationary point on the curve, this quadratic curve. Okay. There can be one logical way of doing this by finding the midpoint of these two x-intercepts, or we can differentiate it. Let's choose the way of differentiating. So if y is this, then we will differentiate the function. So in differentiation, because two algebraic parts with variables are multiplying, we'll use product rule. In product rule, we differentiate one part plus we differentiate the second part, keeping the other one same. So once we differentiate the first factor, in second one we differentiate the second factor. So the differentiation of x plus 3 will be just 1. And this will be x minus 4. Differentiation of x minus 4 will also be just 1. So it will be just x plus 3 multiplied by 1. So what do we get? X minus plus x plus 3, which is 2x minus 1. 2x minus 1. Okay. Now for stationary point, dy over dx, which is actually the gradient of tangent at that specific point or that stationary point, is equal to 0, right? So this is dy over dx, I'll make it equal to 0. So 2x is equal to 1 and x is equal to 1 over 2. This is the stationary point's x coordinate, but they said coordinates, that means we need y coordinate as well. So we can find y coordinate by just substituting this half in the equation of the function and we'll get y. So in place of x, I'm putting half plus 3 times half minus 4. So this will be how much? 7 over 2. Okay, and this one will be minus 7 over 2. Yeah. So answer is minus 49 over 4. So the coordinates they were asking will be half and negative 49 over 4. This is the vertex or stationary point of this quadratic function given. Okay, let's go to question 1 part B. Okay, it says on the axis sketch the graph of the same x plus 3, x minus 4, but with absolute. Okay, so since we know the original function, so this means let's draw the original function first and then we will draw the absolute part. Okay, so x plus 3 means x equal to minus 3 is one x-intercept. X minus 4 means x equal to 4 is the second x-intercept. These two give us x-intercepts. So minus 3. Let's make scale. They said sketch, so it need not to be accurate. So this is minus 3, 1 x-intercept, and 1, 2, 3, 4. This is second x-intercept. Our vertex was at half. So 1, 2, 3 and half, 1, 2, 3, half, 1, 2, 3. Okay. So our coordinate of the vertex was half, or stationary point for that matter, minus 49 over 4. This was the vertex, right? So minus 49 over 4 will be about how much? 12 minus 12.25 if I convert to decimal. Yeah. So let's say minus 12.25 is somewhere here. So half is here x coordinate of the vertex minus 12.25 will be somewhere here. So this is the vertex, right? So our original graph would be like this. And this way. Okay, so I have drawn the positive parts solid and the middle parts in dotted line. Why? Because we don't want a negative. Because of absolute, all y values will be positive. So this one which is negative will be reflected and it will be something like, let's say 12 is here. Okay, so this point will be reflected somewhere here. And our own new graph for the absolute function will be this strange looking shape. This dotted one was just for help. I can erase it. That's the graph of absolute function. We have one C part also. Given that k is greater than 0, write down the value of k for which the equation this has exactly two distinct real roots, only two. Okay, so what do they mean by this? If I make this a function which is already there in the question, I will make this also a function y equal to k. Okay, and this function which is y equal to this absolute and y equal to k, they must cross at two distinct real roots. So y equal to k, since k is a constant, yeah, so this will be a horizontal line because y is equal to some constant is always a horizontal line, and that's what I'm going to do here. I'll draw. There is no solution of this in negative side because it will not cross. Y equal to k is a horizontal line like this here. It will not cross anywhere. If it crosses here, anywhere above 0, it will cross at 4 places. So you'll have 4 solutions. We don't want them. So what will we do? We will draw this particular horizontal line at a place where we'll get 2 crossings, and that will get just above this point. So if I draw a line just above this without touching this, can you see? I'm crossing here, and this one is not touching the graph. So this k value will be just above this point vertex, what we got as 12.25 in previous part. Yeah, minus 12.25 was the vertex, but when we reflected it became positive 12.25. So our answer is k, the value of k. In here they said what is the value of k. So value of k will always be greater than in fraction, that was 49 over 4, or k is greater than 12.25. That's the answer. Question number 2. On the axis sketch, again sketch the graph of a sinusoidal function like this for minus 360 to positive 360. They have given us the scale, state the intercepts with the y-axis. Okay, whenever we have such an equation, what I do usually that I change it to this 5 sine half theta plus 4. I changed it. I wrote 4 later and the sine part first. Why? Because we want to start with the axis, always axis. So y equal to 4 is the middle line. So we call it midline or axis. So y equal to 4. This is 10. That means this is 8, 6, 4. This becomes our axis. Our graph will be around, above and below this line. This is the middle line. Always. The constant part of the function. Okay. Now, this is the amplitude. 5 is the amplitude. That means the height maximum of this graph will be 5 above the axis, which is 4 plus 5, 9. So this becomes our maximum. Let's just a guiding line. Alright, and 5 below this will be the minimum. So 2, 4 and 5. This will be the minimum. Okay, so I have drawn these guiding lines. I will draw my graph between these two lines. Minimum is minus 1, right? Maximum is 9. Okay, now next thing is this half. This half gives us the period, and period is always 360 divided by the number which is the coefficient of the variable, independent variable, which is theta in this case. So coefficient is half, so divide by half. That gives us 720 is the period. The difference between two consecutive maximum or minimum will be 720. So we can see that this is minus 360, this is positive 360. Obviously we will have 720 difference between two. So this whole thing shows one period only, one cycle. All right, let's start. Our sine graph usually starts from the center. Yes, the middle line. So it should start from here. But since the period is 360 on the positive side and 360 on the negative side, our graph should look like this, and I'll confirm after drawing this. And so normally at 180 we reach to the middle line again, this axis once again, but because it is half, that means we'll have a horizontal stretch by 2. That means 2 times longer it will become. So normally 180 is where it returns back to the midline. We'll get at 360 now because it has been doubled. Okay, so now they wanted us to state the intercepts. So intercept is, so y-intercept is 4. Question 3. Find the values of k for which the equation, this quadratic equation, has no real roots. So to do that, let's collect all of them to the left side first. So 4x square minus k I will write later. I will write this x first, minus 4kx minus k plus 2 equal to 0. So this becomes our coefficient of x square. We'll take it as a. Minus 4k will be the coefficient of x, which is b, and minus k plus 2 will take as constants. Okay. For no real roots, determinant b square minus 4ac must be less than 0, right? That is the condition, because in our quadratic formula it becomes square root minus b plus minus square root b square minus 4ac over 2a, right? If this is negative, square root cannot be found. That's why we write that it is negative less than 0. So b is minus 4k, so I'll write minus 4k square minus 4 times a is 4. C is minus k plus 2. Has to be less than 0. So this becomes, this negative is also squared, 4 is also squared. So it becomes 16k square. Then minus 4 times minus k will be positive. There are two negatives, so positive 16k. And then minus 4 times plus 2 will become negative 32 is less than 0. Okay, so we can see that all are multiples of 16. So let's divide whole of the inequality by 16 to make it simpler for us to solve. 16 and 16 cancel, so k square plus k minus 2 is less than 0. And now we can factor this. So k square plus 2k minus k minus 2. I split it the middle term, less than 0. K is taken common here. K plus 2 minus 1 taken common. K plus 2. So two factors come out to be minus k minus 1, k plus 2, less than 0. Now, there are some ways of doing this, but I am doing the easier one. since k is positive and k is positive, both of them are positive. So if I draw a graph, the graph will be opening up of this particular quadratic expression left side, if I take this as a function. Okay. Now, if I want it to be less than, their multiplication to be less than 0, that means the negative part, this is the negative part, right? We want less than 0. We don't want the positive parts. That means this one, which is 1, because of this k equal to 1. This is one root, which is k equal to minus 2. This is second, right? This area between the two will give us the negative value, less than 0 value, this one of y, right? And that's why that becomes our, minus 2 should be here, it is a smaller number, and 1 should be here. Okay, so our answer will be minus 2. Minus 2 is less than, no equal sign here. That means minus 2 and 1 are not part of the answer. Only the numbers which are right and left of these numbers will be the one. K is between minus 2 and 1 for it to have no real roots. Question number 4a. Write 3 plus this as a single base 2 logarithm. Base 2. All of them should be base 2. So this is base 2 already. Base 2 already. Only this we have to convert to base 2. Okay. So how can we do that? This should not be a big deal. So suppose log base 2 something x is not used. So x is equal to 3. I want to convert this 3 also to log base 2. Okay. What should that particular expression be, that this x be? So x will be how much? 2 to the power 3. If I convert logs into exponential form, this is how it becomes, which is 8. Right? So it becomes log base 2 8, because x was to be asked, which is equal to 3, log base 2, 8 is equal to 3. So log base 2, 8, I've converted this to log base 2. Then this 4 must go, if I want to combine logs, this 4 must go, and this will become the exponent of the content of this particular log. So content is a, 4 goes and becomes its exponent. This is without any coefficient, so that's fine, no problem. So now 2 logs with same base are adding, that means their contents will multiply. So it becomes 8 times 8 to the power 4. Now this particular is subtracting, so this content will be divided. So it will be log base 2 8 a to the power 4 over b 1 log with base 2. This is how the expression will be. Okay. B part. Solve the equation log. LG is not life is good. Okay. LG is log. This is short form there. That's what they write. So LGX equal to 4 log base x 10. So we can write this right side as log x equal to log base x to the power 10 to the power 4. Yeah, this 4 goes and becomes the 12. Now the problem is the base here is nothing, and nothing means 10. Okay, so their bases are not matching. So what will we do? We will convert this also to base 10 so that we can ignore the logs. So this will remain what it is, no change here, log base 10 x equal to, I'll convert this forcibly to base 10. But I have to compensate this, and that will be compensated when I divide by log base 10, and this becomes the main number here. This is how we convert from one base to the other. This is also an exponential law. Now, look, this log base 10 and 10, they will neutralize each other, so we can ignore this. So this 10 and this log base 10, this will be complete 4 now. This exponent becomes a complete number. So what does our equation become? It becomes log base 10 x equal to 4 over log base 10 x. Now we will multiply these two, cross multiply, and when we cross multiply, they are exactly same. That means I can write the left side as log base 10 x square. Okay, it is not the square of the x, it is square of the whole log. So I cannot bring this 2 in front according to this logarithmic laws. So it will remain like this, equal to 4. Okay. So now to get rid of the square, we will square root both sides. I'll square this and I'll square this. So log base 10 x is equal to plus or minus 2. So plus or minus 2 gives us 2 answers. So one will be that x, when log is removed from one side, the other one becomes the exponent of the base. So base is 10, so 10 to the power 2, and x is 10 to the power minus 2 also. So this one is 100, this one is 1 over 100. And they did not say anything, so you can write 0.01 also. It's the same thing. So we solved the equation. Question number 5 says the polynomial this is such that a, b, c are integers in this, and x plus 2 is a factor of px, and px is divided by x plus 1, the remainder is 20. So we can use remainder theorem in this, right? Show that 7a minus 3b is 39. So since x plus 2 is a factor, so x plus 2 something multiplied by something gives us the polynomial. Okay, that means if x plus 2 is equal to 0, this whole px will also become 0. Why? 0 multiplied by anything is 0. So that means if x is equal to minus 2 in this polynomial becomes 0. So that's what I'm going to do now. So p minus 2, yeah, in place of x I'm putting minus 2 so that this becomes 0. So it will be a minus 2 cube plus b minus 2 square minus 19 minus 2 plus c is equal to 0. So it gives me how much? Minus 8a plus 4b minus 38 plus c equal to 0. Since I want a and b only, so let's put 38 and c on the other side. So minus 8a plus 4b equal to 38 minus c. This becomes equation number 1. Let's see what do we get when x plus 1 divides, but it is not a factor. The remainder is 20. That means the 0 will not be the remainder. It is not a perfect factor. So we'll write 20 in place of this. When we substitute x plus 1, make it equal to 0, x equal to minus 1. So p minus 1 should give us 20. That's what remainder theorem says. So I will write a minus 1 cube plus b minus 1 square minus 19 times minus 1 plus c is equal to 20. So this becomes minus a, yeah, plus b plus 19 plus c. This was plus 38, right? Isn't it? Plus 38. So minus 38 here. I made a mistake here, so I got a clue from here. All right, plus c equal to 20. So I'll again put minus a and b here, and this will go to the other side, equal to 20 minus 19 minus c. or minus a plus b equal to 1 minus c. 20 minus 19 is 1. Okay. Now our target is to get 7a. That means we will have to subtract minus 8a plus 4b from this so that we get positive 7a. So we'll write minus 8a plus 4b equal to minus 38 minus c. We'll subtract this whole equation from the second one, this one. So when we write minus, that means all of them will change their sign. This will become plus, this will become minus, this will become plus, this will become plus. All right. So minus a plus 8a will be 7a. b minus 4b will be minus 3b. 1 plus 39 or 39. Oh, sorry, 38 it was. 39. And this will cancel out. We got what they wanted. 7a minus 3b equal to 39. I made a mistake of 38 here. I corrected that. Okay, let's see B part. It is also given that the derivative of p is divided by x minus 1. The remainder is 1. So first we'll find the derivative of p. Let me write derivative of p here. So I'll differentiate this one, a x cube. A is not known to us. So it becomes 3ax square will be the derivative of the first term. 2bx plus will be the second term. Minus 19 will be the third term. Since c is a constant, its derivative will be 0, so we'll not write it. They said p derivative 1. Why 1? Let me show you why. Because x minus 1 is given by remainder theorem. I'll again make it equal to 0, and when I make it equal to 0, it becomes 1. So that's why the derivative 1. Okay. So it is equal to 3a 1 square plus 26. Is it 26? Oh, sorry, 2bx. It was 2b. 2b times 1 minus 19 equal to 1. They said remainder is 1. So what will that be? I'll focus on only this part. So it becomes 3a plus 2b minus 19 equal to 1. Minus 19 will go there and it becomes 3a plus 2b equal to 20. 1 plus 19. And now we will have to solve these two simultaneous equations, this and this. All right. So let me decide what to do. This is 7a, this is 3a. So I'll use the elimination method. I'll multiply this one. 7a minus 3b equal to 39. This one I'll multiply with, because this is negative 3 and that is plus 2. So I'll multiply this by 2. Second equation is 3a plus 2b equal to 20. I'll multiply this whole equation by 3. Purpose is that 2 times minus 3 will be minus 6b. 3 times 2b will be plus 6b and they will cancel out. That is my plan. So that's why the new equation will become 14a minus 6b equal to 78. 3 times 3a will be 9a plus 6b equal to 60. And now one is minus, one is plus. I don't need to subtract. I just cancel out. Add them. 14 plus 9 is 23. A equal to 78 plus 60 will be 138. That means A is 138 divided by 23, which is 6. A came out to be 6. And now we can find B. We can use, let's say, this equation we can use to get B. Now substitute A equal to 6 in this. 7 times 6 minus 3b equal to 39. 7 times 6 is 42. So minus 3b equal to 39 minus 42. That gives me minus 3b equal to minus 3, which is b is minus 3 over minus 3, 1. So b comes out to be 1. And now remaining is c. And for c, we'll choose an equation where c is also present. And I can use, which one? Let me use this. Minus a plus b plus this. Okay. So I will just use this space. I know b is 1, a is 6. Okay. So minus a, which is minus 6, plus b, which is 1, equal to 1 minus c. Okay, plus 1 is here, plus 1 is here. Both of them can cancel. Minus 6 equal to minus c, c equal to 6. So I got c as well. C is equal to positive 6. 6, 1, 6. Question number 6. We have been given a table. That table we have to use to answer this one. The table shows the variable x and y, which are related by the equation y equal to a bx square, where a and b are constants. Okay. Use the data to draw a straight line of graph natural log y to x square. So natural log y is the dependent one, x square is independent one, and here it is x. That means we will have to change this to x square, this one, and this one to natural log of y. Okay, so what is x square for 1? It is 1. Square of 1.5 is 2.25. Square of 2 is 4. Square of 2.5 is 6.25, and square of 3 is 9. Okay. Now I have to find natural log of 14, and for that I'll use my calculator. Natural log of 14 comes out to be 2.6390. So I will write 2.64 because I need to draw a graph, so it doesn't matter. 2 decimal places are enough. Next comes out to be natural log of 33.3. 3.5055. So I'll say 3.51. Then natural log of 112. 4.72. Then comes natural log of 532.8. 6.28. I'm rounding off every one to 2 decimal places. And finally we have natural log of 3584. 8.18. And hopefully if I plot these points here on this graph given, I will get a straight line. So first one is x square is 1, natural log of y is 2.64, 1, and this is 2, and 1, 2, 3, 4, 5, 6 point. This is the point. 2 almost. So these lines are all in one line. Let me try to draw them, join them by one line, one straight line. Okay, not very accurate, but yeah, we can see that they are on one line. Okay, that's it. That is the part A. Then use your graph to estimate the values of A and B. So use graph, they're saying, not anything else. So let me go back to my graph and try to estimate the values of A and B. Okay. So since it is a straight line, I will write an equation in this format: y equal to mx plus c format. But in this case, I will write capital X and capital Y because they are not normal x and y. This is natural log y and this is x square. So that's why I'm using the capital X. So can you see 2.1 seems to be or since if I've gone little above these points, so let me make 2 as the y-intercept. They said use your graph, okay, so I'm using graph. Y will be y, it's not cap, it will be capital Y, uppercase Y, okay, equal to uppercase X, and M gradient has to be taken from the graph. And what will I do? I'll take 2 points. Let me take these points. This will give me a good estimate. So I'll take this point 9, and this I'll take this as x2 and this as y2, and this let's take x1 and let's take this as y1. So M gradient is y2 minus y1 divided by x2 minus x1, correct? So y2 is 8.18 minus 2.64 divided by 9 minus 1. By the time I calculate this, I would request you to like this video, share with your friends, and subscribe to Math United. It will motivate me to make many more videos like this. Okay, what I'm getting here is about 0.6925. So this becomes 0.6925. But that was not our question. Our question was find the values of A and B. That means V and one significant figure we have to write. So A and B that means this equation should go into this format, and then we can find the values of A and B. So what will we do now? It was capital Y, which was actually natural log of Y. So it will substitute it with natural log of Y. 0.6925. Capital X was actually x square, which was the independent variable. So I'll write x square here plus 2. Now I need to get this format. That means y should be alone. There should not be no natural log in front of y. So y, whenever we removed natural log from one side, we convert it to exponential format. So e to the power 0.6925 x square plus 2. Y is alone, but it is not in this format yet. We want a to be a complete number, and then we want base, not e. It has to be b, something else. So I'll rephrase it. So y is equal to, since these two parts are adding, let me change it. Since these two parts are adding this and this, we can separate them. 0.6925 x square 1 and then multiplied by e to the power 2. Yeah, that's the exponential law. When two bases multiply, their exponents add up, and I'm doing the opposite of that. Now e square will give us a. So y equal to, I'll write the e square first and I'll evaluate this. E square is about 7.38 something, but they want, if you notice, one significant figure only. So e square is coming out to 7.39 almost, but since we want only one significant figure, we will write 7, only 7. E square as 7. Now e to the power 0.6925 to the power x square. That's what we can separate these two. They're multiplying, so it should be an exponent over an exponent, right? Now we'll put e to the power 0.6925 in our calculator, and we get about 1.99 something. So it will be 7, 2 to the power x square. 1.99 can be written as 2. So this is whole becomes 2 and 2 to the power x square, and it is exactly in the format they wanted now. If you look at the format they wanted, y equal to a b to the power x square, y equal to a b to the power x square. So a is 7, small b is 2. We got a and b. All right. Is there a c part also? Yes, there is one. So what does it say? Use your graph to estimate the value of yx when y is equal to 200. we need to use graph to find this. How can we do that? So when y is 200, so y is 200, right? So natural log of y, what will be natural log of y? 200 basically, natural log of 200. Let me see. It is natural log of 200. 5.29, so 5.299. We can say 5.3. So if natural log of y is 5.3, so we'll go to our graph and see 5.3. 1, 2, 3. This is 5.3 here. Okay. All right. Then what is x? They're saying. So we'll go to our graph here and see where it is coming. It is 4.2, 4.4, 4.6. Yeah, 4.7. We can say 4.7. So x square comes out to be 4.7, and we square root both sides. X will be square root of 4.7. So if I find it, it comes out 2.1679, and they want two significant figures. It will be 2.2. That's the two significant figures. Question 7. A part. Given that there is a function like this and you have to find its derivative. So we can see that x cube and natural log x, they are two different parts multiplying and they both have variables. So we can use product rule for this. So in product rule, we'll differentiate x cube first, and we will not differentiate natural log x. Plus, second part we'll just keep x cube as x cube, but we will differentiate natural log x. So differentiation of x cube is 3x square natural log x plus x cube multiplied by natural log x. Its differentiation is 1 over x. So this x cancels with this, it becomes a square. Both the parts of x square. So you can take common x square. 3 natural log x. 3 natural log x, because x square is out. And this is x square, so plus 1. That's it. This is the differentiation. If you want, you can make this 3 as a cube or x cube. It will become the exponent here, but you can leave like this also. All right. Second part. Hence, find 3x square natural log dx. So from 2 to 1. So let me write here. From 1 to 2, 3x square natural log x dx. Okay. So we'll have to match. Hence, since they're saying hence, that means we'll have to match this with one we had. So we had this. Yeah, it is exactly same. Yeah. So dy, I'm not writing dx, I will write dx here. Dy can be written as 3x square natural log x, this one, plus x square, this one, dx. Right? So dx, which was denominator here, I'll multiply it with the right side, and now we can integrate. So the integration of dy with respect to y will be just y. Okay. And the integration of 3x square natural log x is to be found out. So we'll write it as it is. 3x square natural log x dx. That's the question, right? But we know the integration of x square is x cube over 3. Right? And plus c. So this is the integration left. We will keep it on this side. So that is the one, 3x square natural log x dx is equal to y minus x cube over 3 Yeah, this one goes there, becomes negative, and minus c, you can write plus c also, doesn't matter because constant is a constant. Okay, so we got it, and now we have to evaluate it from 1 to 2. And y is not, these values 1 and 2 are both x's, not y. So what, in place of y, what we can do, we can write its value x cube natural log x. So this actually becomes x cube natural log x minus x cube over 3 plus c from 1 to 2. And now we can substitute the values of 2 and 1. So this becomes 2 cube natural log 2 minus 2 cube over 3 plus c. If you ignore c, sometimes people ignore it, doesn't matter because it is going to get cancelled. 1 cube natural log 1 plus minus 1 cube over 3 plus c. So 2 cube is 8. 8 natural log 2 minus 8 over 3. C and C cancel, so we'll not write it. Minus natural log of 1 is 0. So this is gone. And this minus will make it plus 1 over 3. So it becomes 8 natural log 2 minus 7 over 3. So they wanted this format. That means they don't want any 8 in front. So this 8 will come and become power of 8, power of 2. So natural log 2 to the power 8 minus 7 over 3. Now it matches where a is an integer. A, this one has to be an integer. 2 to the power 8 is how much? 256. Natural log 256 minus 7 over 3. So a is an integer, b is a rational number, that's true. So a is 256, b is negative 7 over 3. Question number 8. The straight line 2x plus 1, maybe this, intersects with a curve, okay. Okay, they are not exact ones, I'm just trying to visualize. At points a and b, so this is point a, this is point b. The point C with coordinates 21 over 10 comma k lies on the perpendicular bisector of AB. So perpendicular bisector will be, yeah. So this point lies on perpendicular bisector, maybe here, 21 over 10 comma k. Okay. So find the exact value of k. So my plan will be first to find the coordinates of A and B. Then with the help of that, find the coordinates which is at the midpoint of this. With the help of the gradient of AB, I'll find the gradient of this normal, this perpendicular bisector. And then I will get the equation, I'll substitute this x, I will get k. That's my plan. It's rightly worth 8 marks. Okay. So first, what will I do? I will just substitute these y's by the value of y of the line because at these 2 points, x and y are common. So substitute y equal to 2x plus 1 in the equation of curve. So 2x plus 1, which is this y, plus x, 2x plus 1, which is this y, plus 3x square equal to 15. And 2x plus 1 remains 2x plus 1. This becomes 2x square plus x plus 3x square minus 15 equal to 0. I brought this 15 to the left side. So 2x square and this 3x square. So it becomes 5x square. 2x plus x is 3x. And plus 1 minus 15 is minus 14 equal to 0. Now you can use quadratic formula or something to solve this. I'm splitting the middle term. 14 times 5 is 70 and 10 times 7 is also 70. So I'll write 10 and 7. 5x square plus 10x minus 7x minus 14 equal to 0. So I did not change 3x. It is still 3. 10 minus 7, 3, right? So if you don't understand splitting the middle term, you can use quadratic formula, which is given to you in the formula sheet. So 5x I'll take common in the first two terms. So it will become x plus 2 minus 7 in next one, x plus 2 equal to 0. So 5x minus 7 and x plus 2 equal to 0. These are the factors, and this gives us either this is equal to 0 or this is equal to 0. So x is equal to minus 2. This gives us x equal to 7 over 5. So we got the x coordinate of this 7 over 5, and this one we got 2, minus 2. Okay, now we have to find y coordinate, and now we can substitute in this y equal to 2x plus 1 in the equation of line, which is easier, right? Y equal to 2x plus 1 is the equation of the line, and these 2 points lie on the line as well. So I'll find this. First I will find with this 7 over 5. 2 times 7 over 5 plus 1. So 14 over 5 plus 1. That becomes 19 over 5. So this y coordinate of this is 19 over 5. Similarly, I'll substitute this minus 2 in the same equation. Y equal to 2 times minus 2 plus 1. Y equal to minus 4 plus 1 minus 3. So minus 3 comes out to be this y coordinate here. Now, next step is to find the coordinates of the middle point. And for middle point, we'll add the x1 and x2 divided by 2, y1. That is the formula for midpoint. So midpoint will be 7 over 5, the x coordinate of the first one, plus minus 2, x coordinate of the second one, divided by 2, comma. Okay, so it will be minus 10 plus 7, minus 3 over 10, and this will be minus 15, so 4 over 10, which is 2 over 5. Okay, this is the midpoint. So the coordinates here are minus 3 over 10 and 2/5. Now we need to find k. That was our question, find the exact value of k, right? So what will we do? We'll find the gradient of AB first. Let's find gradient of AB, and you know the formula for gradient, any gradient, is y2 minus y1 over x2 minus x1. So where x1 y1 and x2 y2 are 2 points, and we know them here. So let's find this. Minus 3 minus 19, minus 3 minus 19 over 5 divided by minus 2 minus 7 over 5, which is minus 15 minus 34 over 5 over minus 10 minus 7 minus 17 over 5. So 5 and 5 can cancel out. Minus 34 divided by minus 17 is 2. So 2 is the gradient of this line AB. So now gradient of perpendicular bisector. Perpendicular bisector is this one, which is 90 degree to this original line, will be the negative reciprocal of 2, which is minus half. Right? And we know 2 points now on this. K is unknown, but we know 2 points. We can equate it to this gradient using this formula again, and we'll get k. So let's do it. So y2, let's say this is y2, 2/5, minus k over minus 3 over 10 minus 21 over 10. This gradient has to be equal to minus half. That's what we got here. So this will be how much? 2 minus 5k over 5. numerator becomes that 2 minus 5k over 5. Yeah, I can write 5 over 5 here, so it becomes 2 minus 5k. This becomes minus 24 over 10. Yeah, both are negative. Equal to negative half. Okay, can we cancel somehow? Yes, we can. 5 and 10 can cancel. And 24 and 2 will also cancel, minus 12. So now we have pure fraction on both sides. 2 minus 5k on one side and minus 12 equal to minus half. Now let's cross multiply now. 2 will multiply here, it will become 4 minus 10k. Minus 12 will multiply with minus 1 becomes 12. So minus 10k equal to 12 minus 4. So minus 10k equal to 8. K equals to 8 over minus 10 or minus 8 over 10 or minus 4 over 5. This is the value of k they were asking for. We have one more part to this, which is D part. The point D lies on the perpendicular bisector of AB, again same bisector, okay, such that its perpendicular distance from AB is twice that of point C from AB. Okay, find the coordinates, possible coordinates of CD. Okay, the point C was the one we just had midpoint, right? This is the one. All right, so let's redraw this somewhere there. Okay, that was C. Okay, so what they're trying to say is this, that we had A, we had B, then we had a perpendicular bisector of AB, right? We got the coordinates of all of them. C was somewhere here. Okay, and now there is D, whose distance, perpendicular distance from AB, that means the distance from this midpoint to D, yeah, is twice that of point. So whatever is of C, D is double of that. All right, so what were the coordinates of this point midpoint, which was minus 3 over 10 2/5, right? Minus 3 over 10 2/5. Okay, C was 21 over 10 and K we got as minus 4/5. So whatever is this distance, D is double of that. So D can be here or it can be here also. Double of the distance of this. So that's why they're saying find the possible coordinates. So we'll find this coordinate. Let's call this PQ and let's call it UV. So if D is double the distance from M, that means this is 1:1. From here, whatever is the ratio and whatever is the angle, same will be here. So P minus this will be same as this minus this. That's how we write 1:1. What I mean is this, P, x coordinate of this, minus 21 over 10 will be same as 21 over 10 minus 3 over 10. And this will give us P. So how much it comes out to be? If I keep P here, we get 21 over 10 plus 21 over 10 plus 3 over 10, right? So it becomes 42 plus 3, 45 over 10 or 9 over 2, right? 9 over 2, yeah. So P comes out to be 9 over 2. Same logic will be used for Q also. Q minus 4/5 will be same as minus 4/5 minus 2/5. Okay. So Q will be 4/5 negative, because there are two negatives, it will become positive, but if I take it to the right side, minus 4/5. 4/5 minus 4/5 minus 2/5. So minus 10 minus 8 minus 2 minus 10 over 2 minus 2. So the PQ comes out to be 9 over 2 and minus 2. That's one possibility. Now we have to see that the distance between this and this is same as UV, and this distance is same as this distance, right? That's how we'll get UV, and we'll use the same logic that we used in this one. So let's use this space for that, and it will be that U minus 3 over 10, U minus 3 over 10 will be same as minus 3 over 10 minus P. We got 9 over 2. Yeah, same distance. So U becomes, this is plus 3 over 10, but it comes here, becomes minus 3 over 10. And then minus 3 over 10 is already here, and minus 9 over 2. So it comes out to be how much? Minus 6, and this will be minus 45. So minus 51 over 10. Yeah. Now, same for V also. V minus 2/5 will be same as 2/5 minus 2. Okay, so V equal to 2/5 plus 2/5 plus 2. So that comes out to be 5. 2 plus 2, 4, and then plus 10, 14 over 5. So these are the two possibilities. Minus 51 over 10, 14 over 5. This is one possible coordinates, and this is second possible coordinate. Question 9. The diagram shows a trapezium OABC. OABC. That means this line is parallel to this line. That's why it becomes a trapezium. Okay. All right. OA is 4A. This is OC. OC is C, and CB is 2A, half of it. Can you see? This is 4A. That means direction of both the vectors are same, but the magnitude of CB is half. Okay. The point D lies such that AD ratio DB is 2:1. AD ratio 2B is DB is 2:1. 2:1. Okay. Total, that means the total length is 3, it is 2, it is 1. Okay. The point X is the point of intersection of AD and AC. Okay. OD and AC. Okay. It is given that AX is lambda times AC. AX, where is AX? AX is lambda times AC. Of course, AX is smaller than AC. That means the value of lambda will be less than 1. That is for sure. And OX is mu times OD. Again, this mu will also be less than 1. Okay, because they are shorter distances. Find in terms of A and C, AB. This is A, this is B, and I want in terms of A and C. So there is no AC in this direct path. So what will I do? I will go to O first. So AB, if I want to find out, I'll go to O first. So AO will be by first vector. Then I will add OC, and then I will add CB, and that will complete AB. AO is given as minus 4A, because 4A is in opposite direction, so I'll write minus 4A. Then C is in same direction I want to go, C plus, this is positive, 2A. So minus 4A plus 2A is minus 2A, and C I will write first. That is what AB is in terms of C and A. Alright, there is a part B also which says OD is also to be found in terms of A and C. OD. So I'll start with O, I'll reach at D. So OD. So O is here, I need to reach D here. So what will I do? I'll go to A first, And since I know AB now, I go to AD, which is, they've given here, AD is 2/3. Yeah, 2 out of 3 it is 2. So AD, I will write here, OD is OA plus AD, OA is 4A, and AD is 2/3 of AB. Yeah, this one is 2/3 of AB, and we found AB in previous part, didn't we? C minus 2A. So just simplify this now. 4A plus 2/3 of C minus 4/3 of A. And this A and this A can be combined, so it becomes 12 minus 4, 8/3 of A plus 2/3 of C. That is OD in terms of A and C. Find OX in terms of A, C and mu. So OX, they've already given OX is mu times OD. And it will become mu, and OD is, now we found out, 8/3 of A plus 2/3 of C. Done. That's OX. Now AX in terms of AC and lambda, and AX is given here. AX is lambda times AC. Do we know AC? No. OD we know, AB we knew, but AC we don't know. So let's see what is AC. Let's do it here and then we'll substitute it here. AC. I start with A, I reach C. So I'll go to O first, so AO plus OC, that becomes AC. AO is minus 4A, OC is C. So that's what I'll write here. AX in terms of AC and lambda is lambda times C minus 4A. Positive is written first, so I'm writing C first. Hence find the value of lambda and mu. And since they're saying hence, that means it has to do something with the previous part. Okay. So do we have something common in them? Yes, we do. OX is here, AX is here, and we know OA, right? So we can somehow connect them. So 4A we can write 4A, right? This one 4A is actually OX plus XA equal to OX plus XA. 4A is this equal to OX. OX is this mu 8/3A plus 2/3C. Then XA is opposite of AX, so it will be plus lambda, but we will change this 4A minus C. Why? Because if we multiply this by -1, they change their sign and it can be reversed. 4A and C can be reversed. Alright. Now, we want to find lambda and mu with the help of this. Do we have A here and A on both sides? Yes, we have. Do we have C here on both sides? Yes, but we don't have any C here. So can I write 0C plus 4A? 0. This is 0, huh? Not O. This is 0. Why did I do that? Because A and C are in different direction and they cannot be converted into each other. So only A's and A's can be converted and C can be compared. So that's what I'm going to do now. 4A, I'll take from here, 4A equal to, I'll take this one, mu 8/3A and then plus lambda 4A. Since all of them have A, we can ignore A. Yeah, so it becomes a equation 4 equal to 8 over 3 mu plus 4 lambda, right? Similarly, we'll write one equation for C also. So 0 is equal to mu, this one, and 2 over 3c minus lambda c. Yeah, lambda times c, and minus because of this. This was positive. All right. So from this, we can say this 0 c I can write here. The c and c cancel. All c's cancel. So it gives a new equation which is 0 equal to 2/3 of mu minus lambda. Okay. Now we have two simultaneous equations. This one and this one. If I multiply this by 4, I will get 4 lambda in this one, minus 4 lambda, right? So I will write that one here. 4 times 0 under this, 0. 4 times 2 over 3, okay, is 8 over 3 mu. And then minus 4 lambda. Alright, so 4 and minus 4, they cancel out. 8 and 8 will become 16 over 3 mu. And 4 plus 0 will become 4. So mu comes out to be 12 over 16. Cross multiply. 4 times 3, 12 divided by 16. Which is 3 over 4. What about lambda? We can use here the value of mu. This one I can substitute here in this one. So 0 is equal to 2/3. Mu is 3/4 minus lambda. So lambda can be taken to the left side. Equal to 3 and 3 cancel, 1 over 2. Got the value of lambda as well as mu. Question number 10 says solve the equation, this one, between minus 180 and positive 180. So we can clearly see that this looks like a quadratic equation, and let's convert it to quadratic equation by assuming that let tan theta equal to x. So it becomes 7x square plus 5x minus 2 equal to 0. And we can simply factorize this. I'm doing it splitting the middle term as usual. You can use your quadratic formula for this. 7x square plus 7x minus 2x minus 2 equal to 0. 7x taken common, x plus 1 minus 2x plus 1 equal to 0. So 7x minus 2, x plus 1 equal to 0. So multiplication of two factors is equal to 0 if one of them is equal to 0. We don't know which one. So we'll equate both of them equal to 0 separately. So this is equal to 0. So this gives us x equal to 2 over 7. This gives us x equal to minus 1. And x was my assumption. Actually, it was tan theta. So tan theta equal to 2 over 7 positive. Tan theta equal to minus 1. This gives us two possible solutions. But we need to find theta, not tan theta. So let's focus on this one first. So we know tan theta is positive in this quadrant and this quadrant. So we will draw an acute angle with the help of tan inverse 2/7 in these two. So this angle will become minus, because we want from minus 180 to positive 180, and this becomes positive. So these two angles will get. Okay. So let's start with the positive one first, and we'll put tan inverse 2/7 in our calculator. By the time I'll do that, I would request you to like this video, share with your friends, and subscribe to Math United. That will give me motivation to make many more videos like this. What I'm getting here is 15.94. Since degree is one decimal place we have to show, so it becomes, we'll write 15.9 only. So this angle is 15.9 degrees. This angle will also be 15.9 degrees. So the first answer, let's call it theta 1, is 15.9 degrees itself. Second answer will be in negative direction, minus 180. This is minus, in this direction is positive 180, in this direction it is minus 180. But minus 180 plus 15.9. So minus 180 plus 15.9, and that should be 163.1. No, 164.1 degrees, right? So this one is done. Now here, theta is tan inverse minus 1. And tan is negative here and here. That means our angle will be in this quadrant and this quadrant. And we know tan inverse 1 is 45 degrees, right? We will ignore minus because we already got the quadrants. That is the job of minus. So tan inverse 1 is 45 degrees. This will be 45 degrees. And this will also be 45 degrees. So first angle in negative direction from here to here will be minus 45 degrees itself. And the fourth angle will be in positive direction from here till this line, which is 45 degrees less than 180, positive 180 this time. 180 minus 45 degrees, which is 135 degrees. So we got 4 answers here. Moving on to B part. Solve the equation this. Okay, and nothing to do with A part. Alright, we'll solve this. So what can we do first? We should remove this 2 from the angle we want to find out. So it will be 3 sine 5, we call it 5 minus 1.5 equal to 2. Now this 3 should go. So I'll divide both sides by 3. Right? Now this sign must go. So 3 phi minus 1.5 equal to sine inverse 2 over 3. Okay. So we have to find from phi from 0 to 3. Right? But this 3 alpha will ask us to go beyond this, so that if we divide by 3, it will come back to this one. So let's see, where do we have sine positive? Sine is positive in this quadrant and this quadrant. So the acute angle which will be given by sine inverse 2/3 will be 0.7297. 0.7297. This will also be 0.7297. So please evaluate this before operating this one here. So we will find phi, we'll isolate phi first and then we'll apply this one. Okay, so let's say 3 phi equal to sine inverse whatever we'll get from here plus 1.5, right? This one, this minus 1.5 goes to there, becomes plus, so it will increase it further. But this 3 will divide it by 3 and make it smaller. So no need to worry. Sine inverse 2/3 plus 1.5 divided by 3. Okay, so let's put the first angle now, 0.7297 in place of this. So the first solution for this will be 0.7297 plus 1.5 divided by 3. Second answer, I will evaluate this later together with other angles. It will be this angle, which is pi. This pi, right? If I go up to here, but this angle, which is my answer, will be 0.7297 lesser than this. So pi minus 0.7297 plus 1.5 divided by 3. This is our second answer. Can we have third answer also? So if 1.5 is added to this, it will go further than 1/3. Maybe it will reach here. Okay, because our upper limit is 3, which is almost pi, right? So maybe this will also give us the answer. So I'll go to third answer. If it doesn't work, then I'll reject it. Okay, the third answer is starting from 0, reaching 2 pi, and then 0.7297 again. So 2 pi plus 0.7297 plus 1.5 divided by 3. Okay, I can go to fourth one if this is little far from 3. Okay, then I'll go to the fourth one. Means I'll go up to here again. All right. So let me evaluate these three separately. So these are the three answers I got when I place this in my calculator. This I can, three significant figures I want to give answers. So 0.743. This can be written as 1.30. And the third one will be 2.84. These are the answers I received. Question 11 is about arithmetic progression, and they are first three terms they have given here. Okay, so we have to find the sum to n terms, giving your answer in form of this. Find the sum to n terms. That is first n terms they're talking about, where k is in terms of n. All right. So, what is the sum of n terms? It is n over 2, 2a plus n minus 1 d. So first term we know, log base x3. D we need to find out. So let's find d first. Let me find d here. D is the difference between any two consecutive terms. And there are first three terms, so I can do log base x 81 minus log base x, the first term, 3. Right? Two logs with same base are subtracting. We can simplify this. Log base x 81 divided by 3, which is 27. So this is our d, and first term is known and all that. Okay. Find the sum to n terms, giving your answer in this format. Okay. So Sn will be equal to n over 2 times a. First term is log base x 3 plus n minus 1 d. We just got log base x 27. Since they want in terms of log base 3 here, log base x3, so that's what I'll do here. I'll keep it as it is. This one also same, plus n minus 1, but this one I'll write log base x 3 cube. Yeah, 27 is 3 cube, and this 3 can come in front and it will also become log base 3 x3, base x3. So n over 2 log base x3 plus 3 n minus 1 log base x3. Now they have exactly same variable part, so we can take that common. So n over 2 was already out. This also comes out. Log base x3 also comes out. So what is left here? 2 plus 3n minus 3, 3n minus 3, and this is also out. Okay, 2 minus 3 is minus 1. So n over 2, and this will become 3n minus 1. I'm writing it first, right? 3n minus 1, this one, and log base x3. That's it. So k is n over 2, 3n minus 1. That's what they wanted, where k is in terms of n. This is k. Okay, B part. The first three terms of GP are this. That means they have nothing to do with the A part. Alright, find the value of theta for which the geometric progression has sum to infinity. So something has sum to infinity when r is less than 1. Yeah, that's what we'll keep in mind. So r is 3 tan square theta over 1. Second term divided by first term is r. Okay. Find the value of theta for which this geometry has sum to infinity. Okay. So that means this is less than 1. Okay. So what will we do? Tan square theta is less than 1 over 3 by cross multiplication. Yeah, 3 comes down. Now we'll square root both sides. So this becomes tan theta and less than plus minus 1 over square root 3. But because of this minus, this has to be here. And only plus we'll write. So tan theta lies between minus 1 over 3 and 1 over 3. Just keep in mind that the r cannot be 0. Okay. Though we have one negative, one positive, but 0 cannot be there. We'll keep that in mind. Okay. Now theta will be tan inverse 1 over square root 3 and tan inverse minus 1 over square root 3. Okay. So if we know that tan is positive here and negative here, that's possibility is there that tan inverse 1 over square root 3 is here and tan inverse 1 over square root 3 will be pi over 6. So pi over 6 and this is minus pi over 6. But they are asking for theta between 0 and pi by 2 only. Okay, that means this needs to go only pi by 6. So theta is less than pi by 6. That's what I can say. However, we cannot have a negative. We can have only more than 0. So I will write 0 is theta is more than 0 but less than pi by 6. That is our solution. I hope you liked this video. If you did, give it a thumbs up, share with your friends and subscribe to Math United. Thank you very much.